Alright, welcome to another video lecture. This is going to be a lecture that I think will help us, so you don't have to listen to me in class, kind of lecture about this. This is going to be a little history. And we're talking about matter. Anything that has a mass and takes up space is called matter. It can be solids, liquids, gases. And we're going to kind of go to do this kind of the history of how the atom was discovered just a little bit. So you're going to find this on page 19 of your packets, and I will get this into presentation mode here and show you how this will work. So we're not going to do all of this. I'm actually going to split it up, and I'll tell you when to stop, and then I may give you some time in between to maybe answer a question or see if you can answer a question. And if you can't, this is a kind of thing we can talk about when you come to class. So we're going to talk a lot about the atom. The atom is a very small unit of matter. It's the smallest unit of matter. The first guy to come out that you'll see on websites and things that come out and talk about this idea of matter being made up of these tiny things called atoms. His name was Democritus, and Democritus was Greek, obviously, in way BC 460, and he took material in this like bowl with like what we call a mortar and pestle. The mortar is like a bowl, and the pestle's like this, like a stirring rod kind of. And he took materials and he pounded them up and kind of scrunched them up into this bowl until they were really really small particles. And then he used the Greek word atoma, which means indivisible, which means not dividable, because it's the smallest unit of any particular matter, the atom. So that's Democritus. Now we're going to skip many more years ahead. We're going to go another, gosh, 2,000 years. And in 1808, one of the other guys that you're going to hear about sometimes on websites, his name is John Dalton, the Dalton theory, atomic theory. And he kind of took the idea of atoma, and he decided to go a little more into it. There weren't any real good microscopes at this point, but there were some lenses, and he was looking at things. And he decided that matter was made up of tiny particles, and he said they were sphere or circle shaped, and that they were able to move and bounce around. And he called them atoms. So we tend to think of him as the first guy to ever use the term atoms. About 90 years later, in 1898, we're coming on the 1900s then. Then you get a guy named J.J. Thomson, Joseph John Thomson. And the Thomson model is a very, very well-known model, and we're getting here obviously closer to today, even though we're still far back. And so J.J. Thomson, he came up with a lot of ideas, but let's first say that he had this idea that these spherical things that Dalton called atoms actually could shoot out, or what we call eject. Whoops, let's go back. Eject these negative particles, and he called them electrons. So we usually credit J.J. Thomson with coming up with the idea that atoms have electrons in them, which I'm going to talk about in a different movie. In 1904, again not too far later, close to the same time, Thomson develops what he calls a plum pudding model of the atom, which is not the way it really is, but this is what he thought. Well, he said that atoms are made up of these spherical things like Dalton said, and he said that essentially all this purple in here is positive, and these dots here that he called plums, and the purple stuff he called pudding. These little circles here he called plums, and he thought those were the electrons. So he basically proposed a model that said that an atom is a round structure that's positive, but it has negative things scattered like a chocolate chip cookie all throughout it. He called it the plum pudding model. Again, a soup of positive charge and balancing these negative charges here. Uneven scattering. And then, again, not too far later, around the same time period, we have Ernest Rutherford. The Rutherford model of the atom is the one that is pretty much currently accepted, and it's a pretty simple model. He was doing some pretty interesting experiments with the guy who ended up being one of the discoverers of radioactivity. His name was Geiger, and another guy named Martzen, and they were carrying these experiments out where they were shooting helium at a really thin layer of gold foil. And he found that when he did that, let me show you this picture here. when he put this through the gold foil right there, he found most of it went through. A small number of them were deflected or reflected, like, and bounced back, even some straight back. So this arrow you're seeing here is the helium, and it's hitting this gold foil right here. And this is called the gold foil experiment. Now he saw most of the helium went right through, but again he found that there was this seemed to be a spot kind of in the middle where if the material, the helium, hit the foil, then it would bounce either right back or deflect off an angle, kind of like a pool ball in pool or something, or a tennis ball bouncing off a wall. So he came up with this idea that I'll show you there. There's the arrows there. But he came up with this idea that there's actually something in the middle of a cell called the nucleus, and that is actually in the center, as opposed to thinking that the electrons were all scattered around. He suggested that actually the positive charge was all in the central part of the atom, and we called that the nucleus. It wasn't the end of the story. But that is really how it is today. So his Rutherford's model gets considered today to be one of the ones that's used. But then a few years later, Niels Bohr, the Bohr model of the atom, kind of added to that. He said, yes, I believe that Rutherford is right, and that there's this center nucleus, and that's why the helium was bouncing off, because it was hitting that nucleus. But he proposed that instead of the electrons being kind of scattered around like the plum pudding model, he said that they went around kind of like the planets orbit the sun, and he called those orbits. And it kind of looked something like this. He proposed that there was a nucleus here, and that these electrons actually went in circles around the nucleus. And that is actually true, as we've discovered now, but he's the first one to come up with this idea. Now, I'm going to stop the video here, and I'm going to ask that you watch a different video instead to continue on learning a little bit more about what the atom looks like. So, I hope